This video is for lesson 2.1 problems. You guys had chosen collectively as a class. The most votes went to 25, 54, 64, and 89. And if you are watching these, please make sure that you let us know how we can improve these videos, how we can improve the process, because we are committed to trying to help you find success in this class. And we are trying to get you help outside of this class when we're out of class time to do it. This is one avenue that we're pursuing. So again, if you have feedback, please let us know. Here is number 25. It says find the derivative of the function by the limit process. Yucky, yucky, yucky. Okay, we got to do, just as a reminder, f prime of x is equal to the limit as h approaches 0. Oh, and I'm Miss Schwartz, of f of x plus h minus f of x over h. I sound like Mr. Lakin, but I'm just really sick right now. Okay, 25. So we're going to use this process. So f prime of x here is going to be equal to f of x plus h, which is going to be 1 over, and I plug in x plus h where I see an x. So x plus h minus 1, and then it's minus f of x, which is 1 over x minus 1, and then it's all divided by h. Yucky, 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 yucky. Okay, my wife texted me, so I needed to see what that was. Now, you guys probably wanted some extra credit here. My kids did at least, because I forgot to put my limit. Definitely need a limit, or else we're not going anywhere. If I plug h approaches 0 in, if I plug h equals 0, I get 0 over 0. So I got to keep going. Now, the trick that I told my kids, and I'm sure Ms. Schwartz gave her kids, she gives her kids lots of tricks. I can multiply both sides, and when I say both sides, I mean this big numerator, small, and the denominator, by x plus h minus 1 and x minus 1, top and bottom. I am not going to multiply that out because that is going to be a huge waste of time. So what I end up getting here, when I multiply x plus h minus 1 times x minus 1 to both fractions, the x plus h minus 1's cancel for this fraction, and I'm just left with x minus 1. So limit as h approaches 0 of, and again, there really is an x plus h minus 1 and an x minus 1 here. So it's just left with an x minus 1 minus, and the x minus 1's cancel for this second fraction, so x plus h minus 1. This is all divided by, and everything's on the bottom, h, x plus h minus 1, x minus 1. Okay, next. Again, I am not expanding the denominator. I will simplify the numerator, though. X minus 1 minus x minus h plus 1. Same denominator. And it looks like we got things that will cancel, so those are out of there, those are out of there, and we're just left with the negative h over h, but h over h is gone too, so that's out of there with one negative. So final answer here is limit as h, well not final answer, is negative 1 over x minus h plus 1, x minus 1 here. If I plug in h as 0, I get, I think I have one tiny little boo-boo. I found it. Again, can't get me. Couldn't get it. You really, really wanted to, but there was no way you'd be able to get it. Okay, so I got an x plus h minus 1. This is going to be an x plus h minus 1. Okay, so when I plug in 0 for h, I get x minus 1, x minus 1. I get two of those. Get negative 1 over x minus 1 squared. That is your answer for 25. If I went too fast, feel free to pause the video. I'm going to keep going. Tangent line to the graph of h of x at the point negative 1, 4 passes the point 3, 6. Oh, mola. So first thing I found out is I have h of negative 1 equals 4. That's what that first part tells me. Second part, passes through the point 3, 6. So that's on the tangent line. That's good. Oh, look at that. H of negative 1 is 4. Okay, well, that was easy. But for h prime of negative 1, So the tangent line passes through, okay, so tangent line passes through 3, 6 and negative 1, 4. Well, that's going to be straightforward. Remember, tangent line is derivative. That's derivative. and the derivative is h prime, and I would need h prime of negative 1. Well, the way I'm going to get that is I'm going to find the slope. And if you're not sure what's going on here, let me draw a picture for you here. So here's negative 1, 4. Here is 3 and 6. There's some function. We have no idea what the function looks like. Zero idea. But basically, there's a tangent line that is tangent to the function at negative 1, 4. But as the line continues, it passes through this other point, 3, 6. So if I want to find the slope of the tangent line, because that's what h prime of negative 1 is, slope of tangent, at x equals negative 1 on h. So if I want to find the slope of the tangent, I just need to find the slope between those 2 points. So let's do it. 6 minus 4 over 3 minus negative 1. That's 2 over 4. That slope is 1/2. And that's how you find h prime of negative 1. Again, if this explanation isn't clear, please speak up to one of us so we can help you out. 64. Oh, this is a 5-parter. G prime is 0, so give me the graph of G prime rather. So G prime of 0 is just exactly what I'm going to see here. It looks like it's at, I'm going to call that 3, negative 3. G prime of 3 looks like it's at 0 because those are literally the y values on the graph. Now the interpretation part, what can you conclude about the graph of G knowing that G prime of 1 is negative 8/3? Well, at x equals 1, G of x has a slope of negative 8/3. If we want to add one more word to it, which we'll do in the next unit, G of x is decreasing. Is decreasing at x equals 1 at a rate of 8/3. That's all I can tell you. The slope at x equals 1 is negative 8/3. Now, since the point has a slope, we could also say the function is continuous. Function is continuous and differentiable at x equals 1. I mean, that's true too. So a lot of different answers here. Any one of those would have been fine. For D, same thing. I'm not going to write it down this time. The slope at x equals negative 4 on G of x is 7/3. Or we can say that because the slope exists, the function is continuous and differentiable at that point. Either one of those is fine. Is G of 6 minus G of 4 positive? Okay, so this is called a difference. In calculus, I like to think of quotients. So quotient, so a difference quotient. G of 6 minus G of 4, just bear with me here. G of 6 minus G of 4 over 6 minus 4 is a secant line. G of 6 minus G of 4, we have no idea, but we get over positive 2, so we get some number over positive 2. This is the slope of the secant. Maybe I'm going about this in the wrong way. And let's look at G prime of 6. G prime of 6 is 6, about. And G prime of 4 is about, let's say, 2. Oh, well, those numbers are both positive. Well, the only way you're going to have positive slope values here, because we have positive slope tangent slopes, that means our secant has to be positive too. There's no way you're going to have a tangent lines, but then a negative secant line. I mean, that doesn't make sense. So in other words, I didn't really need to do this part. So in other words, because my slope of the tangent is positive, the slope of the secant is going to be positive, which means G of 6 minus G of 4 has to be positive. And I actually did kind of need to use this, because that means if I have a positive 2 here, I can't have a negative number on top because I expect my slope to be positive for secant line. And if my slope for the secant line is positive, then that numerator has to be positive as well. G of 6 minus G of 4 is positive. F, just quickly, is it possible? No. You need a starting condition. You need an initial condition. And that's going to be something that we'll investigate in February. So need initial condition, really March. Okay, not possible. You can find slope values from an original function graph. You cannot find original values from a slope graph. Last one, because I got to go to class. Determine whether a function is differentiable at x equals 2. Okay, we need to check continuity first. So, check continuity. Limit as x approaches 2 on the left of f of x is going to be 2 squared plus 1, which is 5. Limit as x approaches 2 on the right of f of x is going to be 4 times 2 minus 3, which equals 5. Okay, so the limit as x approaches 2 of f of x equals f of 2. Perfect. All right, now let's go and check. So continuity checks out, so now we'll check differentiability. Does the derivative exist on both sides? We'll do the limit as x approaches 2 on the left of the derivative formula. X squared plus 1 minus 2 squared plus 1, all divided by x minus 2. And then I'm also going to do the limit as x approaches 2 on the right of 4x minus 3 minus 4 times 2 minus 3. And I should remember here that I do need parentheses here. For the green, all divided by x minus 2. I'm going to solve each one of those. I'll start with the blue first. For this one, I'm going to go ahead, there's a weird mark here, and simplify the top. Limit as x approaches 2 from the left of x squared. 4 plus 1 is going to be it's going to be 5, so x squared plus 1 minus 5, which is down over x minus 2. That's going to be the same thing as the limit as x approaches 2 from the left of x squared minus 4, which is x plus 2 times x minus 2, over x minus 2. Looks like I can cancel out a couple factors, evaluate the limit, and I get the left-hand limit for the derivative is 4. Let's repeat for the right one. So I get the limit as x approaches 2 from the right of, let's simplify here, we got 4x minus 3 minus 5. 4 times 2 is 8, 8 minus 3 is 5, minus 5 over x minus 2. That means I'm going to get the limit as x approaches 2 from the right will be 4x minus 8, or 4x minus 2, x minus 2 in parentheses, over x minus 2. Oh my gosh, a couple factors cancel there, and I get 4. And because the left-hand limit for the derivative and the right-hand limit for the derivative both equal 4, then we can say that this derivative is truly 4, which means, is the function differentiable? Yes, the slope on the left and on the right are the same. So, differentiability is kind of a lengthy process, but basically you have to do continuity first, always check to see if the function is continuous, because if the function is not continuous, the function is not differentiable. So you want to make sure you check continuity first. Then the second thing you want to check is the differentiability. And for later on, we'll have some shortcuts, product rule, power rule, chain rule, quotient rule, things of that nature, that will allow us to be able to simplify this a little bit easier. That's it, guys. Thanks for watching.